Okay, this seems to this seems to be working. Yeah, yeah. So today, um, today we can delve a bit into Redux. What is this all about? Why are people so excited about it? Um, as we'll go through this exercise, and this exercise is going to be very simple, um, but it will get your feet wet, and you'll have a good understanding of why you use Redux, why it's awesome, and why you should start using it on your own projects. Now, there's a couple of caveats with the way I'm going to go about this. Um, so first of all, I'm gonna use the approach that Serge did with combined feedback, but you'll see that by the end, as long as you as long as you understand the fundamental pieces about Redux, it doesn't really matter which library you use. Ultimately, you can even use your own stuff. It doesn't matter. So what we're gonna do today is we're gonna use uh, the iOS playbook interview demo API as an example. Nothing really fancy. We're just gonna fetch a couple of posts, right? From here, we're gonna parse them, and then we're just gonna display this, right? Nothing too fancy, but we're gonna use Redux to achieve that. So I already have this project set up. It has, sorry, it has combined feedback as a dependency. I use Swift Package Manager to do it. I did it before this stream started because sometimes I have to fiddle around with the settings. Sometimes it works, sometimes it doesn't. So I didn't really want to waste anyone's time going around with it. I also have the post itself, so the struct itself, and you can see that it sort of mimics the JSON the JSON blob we have here. Again, nothing too special about this. And so let's start. So the first thing we're gonna do is we're gonna create our content view model. Yeah, I'm gonna create our content view model. This is gonna be a class, and yeah, and initializer doesn't too much at the moment, and now this is the sort of exercise that you're gonna go through every single time that you use Redux, which is pretty much defining the states or possible states that your app might have. And this is an extension on the content view model. We're gonna call it's gonna be an enum, although it could be a struct as well. It doesn't have to be an enum. If you want to share, or if all the different states that you have share have some similar properties, it might make sense to use a struct. In this case, I'm going to use an enum. I find it's enough for this exercise. So the first thing we have is the loading state, which is when you're actually fetching something. You still don't have that something, but you're fetching. You have another state is did receive posts, which is actually when you have when you receive those posts and you have them parsed, and we'll have did fail, which it's what happens when things didn't work out as you expected, and it will fail. So the thing with did fail for now is there are a couple of ways of this fetching to fail, right? You have the network, right? You just made HTTP request, for some reason it failed, and you also have the parsing part. So you're parsing the blob of data that just arrived. For some reason it doesn't work, so you're forced to well, it fails. And the way to sort of, because you have these two distinct types of error, the way to sort of put them together is gonna call it core error, but you could call it something else. I'm gonna say that when it's a network error, you have a URL error, and when you have a parser error, I'm just gonna put a string as a description of something that went bad. And okay, so this sort of I'm missing foundation. Put foundation. What is happening here? This is fine. Okay, so we have the error. If you're doing this on your own project, you probably wanted to put this in its own file. For the sake of this exercise, it's fine to be here. Now, the second thing that is important in Redux is the event or action. It really depends what your implementation calls it, but they pretty much boil to the same thing, which is how do I go from one state to another? And one way to look at this is if I'm loading, right? If I'm at on a loading state and I want to go to receive, to did receive, how do I go about this? And we can call it received, and we can say post, and you can call it failed core error. And this what this says is the following: if I'm loading and I receive the posts, right, I'll go to did receive. However, if I'm loading and I get a fail, then I'm go to did fail. And this is how you should look at this. These two are sort of, you'll probably see them independently of what implementation of Redux you use. The final one, and this is sort of the expected one, and this is why it's called Redux, is you actually have a function called reduce. And this goes from a state, an event, to state. And for now, we'll just do fatal error just to cope with this. And this is what, again, this is the fundamental piece that you'll see pretty much everywhere. The state, how you go from one state to another, and this is the logic that defines how those not transformations but changes happen. For example, we can actually do that right now. And the reason why I'm doing switch on the event and not switch on the state is because I don't really care what is the previous state. I just care about the event that just arrived. So if I'm on, if I get a received, then I know that I should go to did receive, right? The same way, if I would have a failed, I know that I'm going to did fail, and that's it. So this is a very simple reduce implementation, but this is sort of, this mirrors well, or at least it tells very well what is the behavior we want from this machine. So this is a state machine, right? You have the different states, you have the different way those permutations might happen, and finally this is the logic. And this is also the advantage here, is that it's very easy to test. Is it's a pure function. You have the state, you have the output. It's a static function. That's important because it means it cannot access the other variables that might be here. So that's actually very important as well. Okay, so this is how it is right now, and I'm going to use combined feedback. And again, I don't want you guys to focus too much on this, because again, this is an implementation of Redux, but there are plenty out there, right? And you don't really need to use this at all. This is more for you to sort of get a feeling of how this works. And what this does is you sort of need to do a super init, because that's what the view model asks you to do. Um, and this is where the magic happens, right? This is where you create the system, or how the system will behave. And the first one is the initial. So this is the initial state. This is sort of how your state or how your system is initialized. And we can sort of say, okay, it's loading. So as soon as it starts, I'm going to say that this is loading. The feedbacks or feedback loops, which is where's the logic or business logic that we want to work on. I'm going to put empty for now, but we're going to work on this very very soon. The scheduler, as you saw from the last session, I wasn't really sure what was this scheduler. I wasn't sure if scheduler was where the events are gonna uh, come, or where the feedback loops are going to be executed, and actually it's the former. So this is where the events are coming from. You could actually have seen this. Where is it? You could actually have seen this on your own. If you keep drilling system, you can actually see here that again I'm at combined feedback. I'm not on this project's code at all. You can see here that is received on schedule, so you do know that this is happening. This is where the events are going to be delivered. And you can come back and you can say, okay, I want this to be done on the main queue. And finally, the reducer, which is just this very simple function, and you can just say reduce. This is failing. Why it's failing? Okay, so the reason. A second. So this was a change that I already had just to try out this sort of this library. For now, I can just say. We'll come back to this in a second. Just going to. Okay, so the content view, so everything is working. The widget is again another implementation detail of this framework, of this library that Serge created. If you check other places, for example, Cycler from Anders, it works in a different way, but ultimately, as long as you understand these fundamental pieces here, then everything will make sense independently of whatever implementation you do or you use. Okay, so this is done, and now let's go to the more interesting bits. The more interesting bits is the actual loops, or where the work is being done. And like we did with the previous with the state event and reduce function, this is going to be part. I like to put it as an extension of content view model. I also like to prefix it with loop. I think it makes it much easier to find. But again, you can call it whatever you want. And I'm gonna say when loading. And this returns feedback on the states and events. And I can say fatal error for now, just for it to compile. And here I can just do this, and this should work. This can be static. Yeah. This needs this, and okay. Okay, this is working. Now, the feedback itself is where you're gonna put the logic, and for newcomers or for people that are new to Swift, this might be a bit odd, like the syntax, because you're passing a function to an entity. So you are playing around with higher order entities, and not only that, you're also using parameterized entities like you had with the Vimol. So this might be a bit odd for some people, but you sort of have to get used to this stuff. But again, I like to remark that this is the important bit. This is really the meaty part of it. So the loops with the combined feedback implementation, this implementation is pretty similar to the reactive feedback loop, reactive feedback, the library. It's also pretty similar how RX feedback works. They all pretty much work like this. And the idea of the loops is that every time the state changes, these loops are going to be called, right? And as you might have noticed, this is an array, which means that you can have, I don't know, 2, 3, 4, 5, 20 loops. And all these loops are going to be called when the state changes. This is going to happen. Now, how do you go about not allowing this? Because a lot of times your loops are only interested in in a subset of the state to actually do something. So let's see how we can fix that. You can see here that on feedback, you're returning feedback, so you do exactly the same. You can see as well that you're sort of getting this autocomplete with the underscore. You're like, what the hell is this? A way to fix this, you can just say event, and you'll get the nice autocomplete. And the one we care about is this one here, the effects one. And the reason why we care about this one is because this is the one that actually has the state as input. And we sort of we need to give a bit of a help on the we need to give a bit of help to the compiler, otherwise this won't work at all. We can just put this. Will this work? I need to import combine. Okay, I can remove this, and I think I can remove this as well. Yeah, okay. So what is happening here is that you get a state, and based on that state, you're gonna return an event, right? And this is exactly what we want, because as I said initially, if you want to go from one state to another, you can only do that with an event. The event is what you allow from going from one state to another. Now, the loops are going to be called every time the state changes. So in this case, when loading, you really only care when it's loading. So you can say something like this. So this, what it tells you, what it's telling you is that, hey, if it needs a bit of help here, maybe. Is it? Where is it? It's a case. Okay, so event never. Okay, so what? Just this. Okay, so what is happening here is when you reach this part, you're only going to do something if it's loading. If it's not loading, you're gonna bail out. And this is sort of, you're gonna do this a lot when you're implementing these loops, because these loops, you might have another loop for example, I don't know, analytics, or you have a loop for, I don't know, for persisting on the on disk, or you have a loop to actually make a different call. So you're probably gonna have guards in the beginning of these loops saying, hey, I'm only going to do something when I'm at this state, otherwise I'm gonna bail out. And this is pretty much what we're doing. Now, what you're gonna do on this particular loop is to fetch this. You're gonna fetch this, we're gonna parse it, and we're gonna return to the user. So let's do that. I'm gonna use a URL session to do that. It can be the shared one. Let me just clean up this. I advise on actually passing the parameters if you are in a real project, you probably want to test this. You probably don't want to pass directly URL session, otherwise you cannot test any of this. So this, again, this is a caveat. This is just a way for us to sort of see how Reduce works, but in a real project, you probably would have injection happening here. The same thing here on the init. As you can see, this is an empty init. There's no parameters, but I'll pass here all those so that you can mock these things. So the first thing we're going to do is we're going to use, let me just call this a session, and we're going to do session data task publisher. We're going to put the URL, the string, and this is what we're going to use. This, okay. And now we're gonna map, and this gives you a key path. And I only got to know very recent that you can actually do something like this, and this will work, and it will extract the first parameter from the tuple. If you prefer to be I don't know, a good citizen, you can do .data. And the reason why we're doing this is that we don't really care about URL response. We only care about the data in this case. So so the next thing we're gonna do here is so we have data. So now we actually need to parse this. I already have a small function here. This function I took it from the previous project that you guys can check on part 2. So basically it takes data and returns a result of t. So we can where is it? We can flat map this, and we will have a function that goes from a data to publisher. And if you guys know me, I mean I don't really enjoy doing this sort of stuff. I prefer to just have an auxiliary function outside. I think it makes things a bit more a bit more easy to read. So let's do that. So what we want is a flat map to posts. So I like to read it like where it's being used. So if you're going down this stream, that's how you'd be reading it, flat map to posts. And this goes from data to any publisher of posts, and it gives you a core error, and and I'm gonna put a fatal error here for now, just so we can focus on other things. Sorry, post. Okay, posts. Flat map to posts. Let me see. I see. So what's happening here is that the data task publisher is working with URL errors, and what we're saying here instead is a core error. So we have to make that map happening, and this is fine. We can just say core error dot network, and that's fine. Now we lift the URL error to operate at the core error level, because that's how we sort of bridge between the network level error and the parser error. We just wrap it up, both of them inside this enum. So now we're able to parse this more or less. We still have to actually do this implementation. But next, what we can do is we want to, because we're dealing with events. If you look at this, we're dealing with events. We actually have to map the post into events. So again, we're lifting these posts to operate at a different level, and we can just say received. And now we are working. If you look, let me just do raise to a new publisher, because that's what we want. So if I do return session, let me see what this gives us. So the problem, okay, so we're almost there. I mean, we still have to implement this to posts, but we're almost there. What it's telling us is that, hey, what you returning is a content view model.event core error, while what I really want is actually a never. And the reason why we returning never here is because in combine or reactive Swift or RX Swift, and what we want here is we want to erase this. We don't really want to use a core error, because if a error happens in streams, the whole stream is gonna fall, right? It's gonna stop, and we don't want that. What we want is for it to continue sending events, and a easy way to sort of fix this is by putting the error, right, the failure path, as if it was an event, and this is what we're doing here with the fail core error. And sort of a way to do that is we have catch, which gives you a core error, and what you can do is catch to event. I can actually say catch error to event, and I can say to event, and it gives you a core error. And what we want here is any publisher, and that takes posts and turns never and in, and we can just literally just do this. Actually, this is an event here, and we can say error in just dot init event dot failed error dot. I think we can just put I don't think we need to do this shenanigans with erase. What am I missing here? Oh. Oh yes, this is that. And then you have to sort of erase. So you want to erase at the very bottom, so it can, you don't even need this anymore. You could actually go through the same exercise here, and you don't even need to say posts. You can just say event, and you can remove this to make it a bit easier to understand what's happening. And the actual implementation of this would be by using this function, right? And you just say decode. This here is data. Decode data, and you have your data, and then I don't think it's able to actually understand the type we want, so I'm just gonna give a couple of hints here. Post core error, right? Okay, now you can say result map posts to event dot received, right? And then you can say publisher. What is happening here? should complain cannot convert. Yeah, what we want is this thing over here, result dot. I find this syntax a bit confusing, but that's fine. And yeah, and it's working. Okay, so you have. Okay, so this there's a lot of stuff going on here, but ultimately, this looks pretty good, right? You're doing a lot of stuff here, and it's actually 1, 2, 3, 4, 5, 6, 7 lines of code. You can remove this 7 lines of code that are sort of easy to understand, even if you don't know combine, or if you don't know feedback, or if you don't know loops, what the hell is going on here. But this particular bit is actually sort of okay to understand, as in session, you're fetching something because you have the hint that you have a URL here. You then, this might be a bit awkward with key path for a newcomer to understand what is happening here, but you're getting the data out of it. You then you're mapping the error here, so your error from the URL session is operating as a core error. You then flattening map to posts, so you're converting this data into actual posts, and then you're catching error. So if something bad happens, you're just pretty much just passing it to the right event with the failure, and there's nothing else happening here. So this is okay. So this is fine. Okay, so this is cool. I feel that this is pretty much it from a view model point of view. So now let's look at the content view. The content view, it follows it's again, it's slightly different than what you used to, but again, different frameworks will require you to do different things, and it's absolutely fine. You just have to sort of accept what they decide to do, either agree or not, and then you can use a different implementation. The one from Serge, it's I find it all right. Although I will still look a bit more deep into what Anders is doing here, but yeah, they all sort of funnel into the same thing. In the case of the combined feedback, you use a widget to sort of tie the view model and the view. So I don't know it by heart how you do that. So let's look at the example he has. Where is the example? Where's the example? The example. Is it the counter example? I think it's the counter example. So this is the view model. We already have that. And from a view point of view, the only thing you do is this stuff here, which I can copy paste. Just need to be careful because it's not called counter view, it's called content view model. Content view model. It doesn't really know what the context is, so we have to import combined feedback UI. This is okay, and now on the scene delegate, so this is where I just had a quick run with it. This is where you have to create something called a widget, and here you pass the content view.init. So the function, so it's the function that allows you to create a content view. There's a missing. What is missing? What is missing here? Is it missing something? No, it's not missing anything. So the widget is the view itself. Yeah, exactly. The view, yeah. Okay, and as you've seen on the previous session, what I like to do is say something like render the context, and it then have func render. You have the actual context. I think I can do this. Yeah, I have to be honest. I actually really like static functions or free functions. I really enjoy, because it's a nice way for to be disciplined, because it forces you to not use any state. It forces you to be only use the input of your functions, and that's really powerful. So in this case, you get the context, and the context is basically this stuff here. And we're gonna return. I'm gonna return an any view for now. I can just do fatal error here just for it to be happy about it. Okay. And what I want to do now is I want to switch over the context, and there's nothing here. Why is there nothing here? I want the state. So where is the state? Let me see what he has done. Self.context context count. Okay, so he has a count here. Where did you get the count? Oh, so the count is a property from the state. Okay. But we don't get that with our. We're not using a struct. We're using an enum. So. Can I do something like is loading? Can I do something like this? Will it be happy about this? It is happy about this. Oh, okay. Then I guess I can just. I mean, this is a bit odd. This is very odd, but I guess I can do this. Can I? Jesus Christ. Oh God. Again, this is. I'll. Yeah, I probably will do a PR just to see if I can fix this, because this is not very intuitive. You would never do this. I don't think you'd do this. Yeah, I'll have to think about this. It's fine. It's absolutely fine. Actually, if I go to the context right now. Oh, this is private. And then yeah, exactly. He uses dynamic member lookup. Okay, so the dynamic member lookup is basically yeah, a subscript. Exactly, it's a subscript. Yeah. So the basically what's happening here is he is accessing the properties of the state via key path. But because I'm not interested in the actual properties, I'm interested in the state itself, then I'm not able to do this. But if I would come here, okay, I cannot edit this. Fine. Fine. That's absolutely fine. Yeah, I mean, as they say, whatever works. I can do this. Loading. I can do. What else do I have? Did receive. The posts, and I can say text. Number of posts. Posts dot count, and I can say let's it fail error, and I can, for instance, actually I can just say text and be done with it. This and this, I can say failed, and then error dot localize description. Yeah, does it work? Does this work? Let's see if this works. I don't know if this is gonna work. Doesn't seem to work. Well, nothing is. No, it's still starting. Okay, number of posts 100. Okay, it works. It does work. Which I guess it's a success. It does work, but it does work, but it seems to be going pretty fast. So let's just print the state, and let's print the event just to have a look of what's going on here. Okay, so it's loading, and then it gets a received, which is the event, and then it returns the did receive. Okay, this makes sense. Okay, so the Redux is working. This whole thing is working, but I'm not particularly happy about this. And the reason why I'm not happy is it follows the same logic as we had in the previous session, where you initialize this and this immediately starts working and doing things, and you're probably not even on the view. The view might not even be ready, and this thing is already working, which I mean, I don't think makes a lot of sense. So something that we sometimes do is adding an initial state, and this initial state doesn't do anything at all. It doesn't do much. It's just a way to say, hey, when you're in the initial state, you're gonna wait for something to happen until you start running the loops, and that you actually need an event for this to start, and I can call it start. And on the reduce, I can say case start, and I can return dot loading, and I think it sort of makes sense. Like you send an event saying, hey, start this thing, and that's when the actual this fetching actually starts. And this, you can imagine this start being, for example, pull to refresh. You can call it fetch, right? You're just saying, hey, fetch, and then from fetching it goes to loading. Okay, this makes sense. Okay, this makes sense. Now, okay, so let's run this, and you'll see that this doesn't do anything now because, well, first because it doesn't compile, but okay, it needs the initial. I can put the initial here for now. It doesn't. I can put the initial here for now. It's all right. The same outcome for the loading. And you can see that nothing really happens because you haven't told the machine to actually, hey, start doing something. I mean, the machine is running, but it's not running as we want it to run. It hasn't reached this, right? This is like, the initial is like the -1 step, or the nil step. It doesn't start doing anything, but we have to tell it to run. But from the previous session, I think, is it did appear, or is it on appear? I never remember. Yeah, on appear. Okay, on appear. And what we did last time was something like, we're gonna tell the machine to actually do something, and actually with combined feedback you get a lot of this stuff for free. One of these things that you get for free, and it's actually very powerful, is a way to influence the machine from the outside. And you can just say, hey, do the fetch, right? You can actually do this, and this is actually pretty nice. If you're not okay, this is not working, and I know now why it's not working. We're gonna fix it in a second. But the point I'm trying to make is, if you're using combined feedback, if you're using Redux on your own, having a way to influence the machine from outside, or sending events to the machine from the outside, it's a double-edged sword. And the reason why is because a machine shouldn't be influenced by outside sources, but on the other hand, it's very useful to do so. It's very pragmatic to do so. The way I fixed this was like this. You do a dispatch queue on the main with a sync, and you pretty much do this, and context, yeah, that's fine. And and this should exactly. So now it's working properly, and it's doing things the way we want them to do. So if we just do this instead, print state, print event, doesn't matter. Okay, print event, print state, and okay, so you can see that you get fetch initial. Oof. Oh yeah. So the first. Wait a second. Now I'm slightly confused about this. I'm slightly confused about this. Let's see what's happening here. Okay, events fetch, the current state is initial, which makes sense. Then you get an event of received, and the state is loading, and this makes sense, right? So the first state that you are in is the initial state, right? This makes all sense. And then you get event fetch from the content view right here, and because the state is initial and you get a fetch, so you get a fetch, now you're in loading, right? So the loading now, it hits here, and it'll try to do all this stuff, and when it does, it will emit the event received, and this is what we get. And something that is important for you to notice is if you run this the first time, it's going to be called, right? I need to print this. Jesus Christ. Nonsense. So the first one is initial, but because we only care about when it's loading, it's going to bail out. You see, it's going to bail out. And this is sort of the mindset you get into. Like, the feedback is always getting called with all the state changes, but you only care in this particular case about the loading. And I guess that's it from my side. This is a very simple implementation of Redux. There's just very particulars about this. One is that this is at local level. This is the Redux machine for your screen. This is not for global state, which a lot of implementations out there actually, not necessarily implementations, but approaches use or put that machine or this Redux at the global level. Sometimes this is desirable, sometimes it's not. By default, I would probably put it on the local level. I find it easier to reason about. And in particular with combined feedback, you will see a lot of different implementations. For example, you have a cycler from Anders. If I'm not mistaken, it works in a different way. Then I don't think it's bound view. I think it's just for you guys to have. Where is it? Yeah. Here. So for example, if you look how the reduce works in our case, the reduce goes from state event to state, but there are other implementations where the actual reduce will be from reduce state in out state event, and then that's it, void, and it actually will change the state inside. Again, this is just a different implementation, but the basic idea is still the same. There's only one way to change state, and that's via the reduce function. And that's it. Thank you very much.